Today we will talk about game theory. Let's start with a story. Picture two criminals. Let's call them Alice and Bob. They've been caught by the police and placed in separate rooms. The cops don't have enough evidence to convict them on the main charge, so they offer each one a deal. If Alice rats out Bob and Bob stays silent, Alice goes free and Bob gets 10 years. If Bob rats out Alice while she stays silent, the roles reverse. If they both rat each other out, they both get 5 years. But if they both stay silent, just 1 year each. What should they do? This scenario is called the prisoner's dilemma, and it's one of the most famous problems in game theory. At its heart, game theory is about how people make decisions when the outcome depends not just on what they do, but on what others do too. It's the mathematics of strategy. In the prisoner's dilemma, the logical move for each prisoner is to betray the other. That's the dominant strategy, the one that gives you a better outcome no matter what the other person does. But here's the twist. When both follow that logic, they end up worse off than if they had cooperated. This is one of game theory's key insights. Acting in your own self-interest doesn't always lead to the best overall outcome. This brings us to the concept of Nash equilibrium, named after mathematician John Nash. Yes, the one from A Beautiful Mind. A Nash equilibrium is a situation where no one can improve their outcome by changing their strategy, as long as everyone else keeps theirs the same. It's stable, but it isn't always ideal. The prisoner's dilemma ends in a Nash equilibrium. Both prisoners betray, but it's not the best possible outcome. It's just the most stable one. So how do people actually make decisions in the real world? Game theory starts with the assumption that people are rational, that they'll make choices to maximize their benefit. But as we know, humans are often anything but. That's where behavioral game theory comes in, which tries to blend strategy with psychology, recognizing that emotions, fairness, and even revenge play a role. Imagine two people splitting $100. One person proposes the split, say $90 for me and $10 for you. The other person can accept or reject it. If they reject, neither gets anything. What would you do? Game theory says take the $10. It's better than zero. But in real experiments, people often reject unfair offers, even at a cost to themselves. Fairness, it turns out, is a powerful force.